I believe everybody can hear me. All right. So we're going to start the class today. I have some series of questions that I think will be useful for us for this evening, for today. Okay. We are going to touch on some questions as well. I could remember the last time, I think we discussed Surds the last time. Okay. And we can check out questions that borders about Surds rationalization, and possibly after that we can quickly move to other topics like quadratic equations of different sorts, like that. Okay, so let's just round up on Surds, then we can check out this question. I remember I said that we can add Surds, we can multiply Surds, we can divide Surds, and we can also get some other questions that has to do with Surds done with some level of experience or expertise that we're going to discover tonight. Okay, so we are just continuing on Surds. Okay, all right. So the last one we mentioned was if you have root A times root B, it will also give you root AB. And if you have root A times root A, you are going to have A as your answer. The same way for division, if you have root A over root B, of course, it will generally give you root A over B. So all of these are allowed. And the converse is also true. Square root of A over B can be splitted up into square root of A over square root of B. But now, for rationalization, all right, when you have root A over root B, this question is going to be modified. We are not changing the value. We are only modifying the nature of this question. So when you have this, it can be termed to mean root A over root B times root B over root B. Now, what you will agree with me is that root B over root B that we are using to multiply, of course, root B over root B is 1. So when you have root B over root B to be equal to 1, what it means is that we are just multiplying root A over root B by 1. And anything multiplied by 1 is that number. But for the sake of the way we are going to change the nature of the equation, root A times root B, of course, you multiply the numerator, you multiply the denominator. So you are going to have root A root B all over root B times root B, which is the same thing as root AB all over B. This becomes necessary because a rational number or irrational number rather cannot be the denominator of a fraction. When an irrational number becomes the denomination of a fraction, the whole fraction becomes an irrational number. So in order to remove that condition is why we have to go about this rationalization. Because when you divide a normal number by a number that has a repeating and non-terminating decimal, Hello, can you hear
Okay.
me? Okay. All right. So can I continue?
Yes, please continue. Sorry, I thought I was muted. Sorry.
Oh, okay. Now I get. So when you have a number, whether rational or irrational, divided by an irrational number, the whole expression becomes irrational. And let me quickly use this to remind you or bring any number or any fraction where you have zero as the denominator renders the whole fraction undefined. So please note that. The same way for irrational number, when you have root 2, when you have something over root 2, the whole expression becomes an irrational number. So in order to eliminate that condition, is why you have to go about this rationalization. Rationalization means you are turning it to become a rational number. From being an irrational number to being a rational number. That's what you have there. Okay, so I'm going to be showing you that is for rationalization. Now, we have two types of rationalization. The first one you had was, let me show you again. This particular one is called a single rationalization, whereby you have only one single expression as the denominator. So it is possible you have a number with double expression, like something like root 2 or 2 over root 3 minus root 5. When you have something like this, then the method of rationalizing this expression is quite different from when it is a singular irrational number. So the first thing we are going to talk about here is conjugate sorts. There is something we call conjugate. Conjugate. It's called conjugate sort. A conjugate sort is a sort that when you multiply it by its conjugate, you are going to get a number, not a sort, but a whole number. And to get the conjugate sort is very easy. If you have a conjugate, if you have root a minus root b as a sordic expression, especially when it is double expression, the conjugate of this sort, conjugate will be equal to conjugate will be equal to, or let me just say conjugate equals, instead of writing long story, conjugate will be equal to root a plus root b. It's just about using the order of difference of two squares. So the conjugate of a sort root a minus root b will be equal to root a plus root b. Because if you multiply these two sorts together, what you are going to get is an expression without any sodic appearance. And you can quickly check that out. Root a minus root b into brackets root a plus root b. If you are good at expansion, of course you should be good at expansion. Root a times root a will give you a. We have established that before. Root a times root b, that is plus root ab. Then minus root b times root a will now be minus root ab. And then b minus root b times root b will give you minus b. So at the end of the day, this one will cancel this one. So you are going to have a minus b. So this one is an ordinary number without any sodic expression. So for anytime you want to determine a conjugate sort, what you need to do is change the sign, because it must be a sort that when you multiply it by the original sort, it will give you a whole number. So that is what you need to do. So the simple shortcut is to just change the sign. And when you are changing the sign, you have to be careful. All right. When you are changing the sign, you have to be careful. You have to change the sign that follows the first one. Okay. In such a way that what you are interested in is that the irrational expression must be cleared off. So you can practice several sorts with its conjugate. It's allowed. Just practice several ones. And then what I'm after is, just like I expressed here, Just like I express here, let me change so that you will see what I'm expressing. Just like I express here, I want to make use of this expression that I circled. How do I rationalize a sort like this? Okay, before I solve this one, or before I use this as an example, I'm just going to give you a prototype way of getting it done. So you're going to have, if you have root a over root b plus root c, the first thing you need to establish is the conjugate of the denominator. You will use the conjugate of the denominator to rationalize, just like we did for the first one. So it's going to be equal to root a over root b plus root c multiplied by root b minus root c all over root b minus root c. So this is the expression for a sordic expression that have double surds as its denominator. So you will use the conjugate of the denominator to rationalize. That is just so the process of rationalization is the same, because root b minus root c over root b minus root c will give you 1. So we have not changed the value, we only modified this expression. We are not changing its value. The value will remain. It's just that we are modifying the appearance of this. So at the end of the day, what you are going to get is root AB minus root AC all over. By the time you expand this, of course, what you are going to be getting is B minus C. And then this now becomes a proper fraction that you can work at. All right. Now that you have eliminated square root as the denominator, then you can now say authoritatively or categorically that this expression is rational. Can you see what I'm saying? Rational. That is, it is no more an irrational number at this level, because it is divisible by an ordinary number, not by an irrational number. So based on all of this, I think it is good to just quickly launch it to some question. That's all about sorts for that we need to know. We can quickly launch into some questions and then check some questions. Let me see. Year by year, as many as we can solve will be fine for us. Okay. All right, we can check. I have a book that I'm using here. So if you have past question with you, you can always check it out to check whether you have it in that year. But I'm going to be using a book where all the years has been sorted out, and then we can actually pick questions as we like from each of those years. Okay, so I'm going to be picking my first question from, okay, a question in question 20 here. Just a minute, please. Okay, so I have my question 20 here. This is 1981 JAMB, and I'm going to write out the question. 1981 JAMB. I don't know which number it is in 1981, but this is the question. Root 2, you have to simplify. Root 2 over root 3 minus root 2, then minus root 3 minus root 2 all over root 3 plus root 2. So they want us to simplify this expression. One thing about JAMB is that whatever calculation you have to do it very fast. All right. Is in JAMB, there are two major things that they test in every exam, but in JAMB, most importantly, we concentrate on it. Speed. You have to do what you are doing fast, and accuracy. You have to be sure of what you are doing. You can't afford to gamble in JAMB. So you have to be very sure and be certain of the answers you are picking. So this is a 1981 question. Probably if you have past question and answer, you can check. For 1981, you are going to see this question there. So I really can't tell which question number it is on past question. So what I'm going to do is I'm going to split it up. I'm going to rationalize this separately I will rationalize this also separately. Then whatever I get as my answers, I will now carry out the subtraction. You can see each expression are standing alone. So I need to do their rationalizations separately. Please note that. And that's why I circled it. So let me take these circles away and preserve. So I'm doing the first one. This will give me root 2 all over root 3 minus root 2. Now, this time around, to rationalize this, I need to use the conjugate of root 3 minus root 2, and that will be root 3 plus root 2. Don't forget that you have to change the sign, and that is what makes it a conjugate. Then all over root 3 plus root 2. So that's what you have there. I want to do it on its own, so that let me see what I can get. If you expand this, what you are going to get is root 6 plus 2, because root 2 times root 2 is 2, all over. This one will now give you 3 minus 2. That is if you know what you are doing. So at the end of the day, 3 minus 2 will give you 1. Root 6 plus 2 all over 1 will just give you root. For you to get it wrong, so it is going to become root 3 minus root 2 all over root 3 minus root 2. So when you do this expansion, we are going to have, I just want to quickly get it done. You are going to have, expanding the numerator separately, you are going to have 9 minus root 6 minus root, that is minus 2 root 6. Then minus times minus will now become plus, so plus 2. That is if you expand it well. That expansion, I should not go over it because I believe you already know how to expand. Then for this one, what you are going to also get is 3 minus 2. So at the end of the day, this one will give me 9 plus 2. I'm going to have 11. So it's going to be minus 2 root 6 plus 11 over 1. Now, let's go back to the previous board. For the first part, we got root 6 plus 2. And now, for the second part, we are getting root 6, minus 2 root 6 plus 11. Okay, let me come again. For the first part, we got root 6 plus 2. This red circled part, we got root 6 plus 2. So I want to bring it up together. Now, not forgetting that there is a minus in between them. So root 6 plus 2. So it's not going to be root 6 plus 2. Root 6 plus 2 minus 2 root 6 plus 11. All right, so we have this. So at the end of the day, it's going to be root 6 plus 2. You can use this minus to expand. That will be plus 2 root 6 minus 11. Because minus times minus is plus, minus times plus will give you minus. So root 6 plus 2 root 6 will give you 3 root 6. It's like you say 1 biscuit plus 2 biscuits. It's going to be 3 biscuits. Then plus 2 minus 11 will give you minus 9. All right. So you can decide to factorize. If you factorize this, there is 3 that is common. So I can factorize into 3 into root 6 minus 3. I can do this. All right. And then, of course, you are going to see your answer should be there. That will be evident. I don't know which option they will give you there. It will be there for you to check. All right. So you have that. Okay. Can we move on? Okay. So let's check another question. This is another question. Probably this one will have been a bit simpler. The question says we should rationalize 1 over root 2 plus root 5. This is 1982 question. You are to rationalize. 1982 question. Rationalize 1 over root 2 plus root 5. Okay. Okay, so here we have this. Now, to rationalize this, of course, the denominator is our focus. So it's going to be 1 all over root 2 plus root 5 times root 2 minus root 5 all over root 2 minus root 5. We are going to use the conjugate because we have double expression as the denominator. Now, at this point now, 1 times everything in the numerator is just that. So I'm going to have root 2 minus root 5 all over 2 minus 5. You are going to get minus 5 if you expand well. So it's going to be root 2 minus root 5 over minus 3, which you can simply write as, it depends, of course. You can actually change it to become root 5 minus root 2 over 3. That is, you multiply. When you are dividing positive number by negative number, it will give you a negative number. When you are dividing negative number by negative number, it will end up being a positive number. So you have that. But in this case, what they did was they separated it. They separated it so it can be separated. I can write it as 1 over 3 into root 5 minus root 2. All right, I can do this. 1 over 3 into root 5 minus root 2. In some places, they can put it, let me just write that with another ink because I want to make it, they can say root 5 over 3 minus root 2 over 3. These are possible answers. It depends on whichever way JAMB want to stretch you. They can stop at this first level. They can go as far as this. They can factorize it. They can even split it into separate fractions, depending on what they have. We just solved the question from 1982. Okay. Let's quickly check again. I have another one from 1984. It may look like we are solving old school questions, but I can tell you because JAMB is now CBT, they might not even bother about trying to set new questions. Really, they can just pull from several questions they have over the years, and that is one of the ability of CBT. You cannot go with your question, so there's no way you can tell whether the one they did last year is the one you are buying in your question paper. Most of the questions are CBT, so you need to go and bypass question and answer. At least rely on the ones you have from 1978 to at least 2018 or 2017. And I can't even remember when they stopped paper and pencil, but then those are the valid questions. So if anybody is printing any question for you that is last year question, you can't trust it. You can't trust it. All right. But at least we are sure that we are able to cover the syllabus and we are well prepared. Okay, so note that. So let us have this. This is from 19. Let me see if I can see a recent one, really. But I think I can quickly address this. 1984 question, 5 root 7. 5 root 7 minus 7 root 5 minus 7 root 5. Sorry, because of the way I'm writing, I'm going to put the bracket just below. It's actually supposed to be beside. It's a multiplication, binomial expansion. Root 7 minus root 5. All right, so we are going to multiply that. So when you are doing this, 5 root 7 minus 7 root 5 into root 7 minus root 5, I can do this expansion easily. I can decide to say 5 root 7 into brackets root 7 minus root 5, then minus 7 root 5 into bracket root 7 minus root 5. You can have this expansion. So at the end of the day, you can do this expansion. 5 root 7 times root 7. You see, you need to be careful. Normally, if I say 5x times x, I will get 5x squared. Now, 5 root 7 times root 7 will give you 5 root 7 square. But you know that the square will cancel the square root. This is what we are interested in. So I'm not going to do that for everything. I'm just going to do that for this 7, then square. But at the end of the day, this square will cancel this. So 5 times 7, that's what I will have. But I will keep this. I can go for the next one. 5 root 7 times minus root 5 will give you minus 5 root 35. That's what you are going to have there. I'm done with the first expansion. Or probably let me just use a black ink. So this will give me minus 5 root 35, because root 7 times root 5 is root 35. Then I'm done with the first expression. Then minus 7 root 5 times root 7 will now give me 7 root 35. And then the last one, minus times minus is plus. So 7 root 5 times root 5 will give me 7 into 5. Root 5 square. The square will cancel the square root. So I'm not showing all of that. So 5 times 7 will now give me 35, minus 5 root 35 minus 7 root 35 will give me 12 root 35. 12 root 35. Then plus 7 times 5 will still give me another 35. So at the end of the day, my final answer will be 70 minus 12 root 35. Yeah. So that's my final answer. 70. Let me change that. I want to use, okay, 70. 70 minus 12 root 35. So this is the answer I have. If I want to expand or maybe factorize by 2, 2 is the common factor. 3 cannot go, 4 cannot go, 5 cannot go. So 2 is the only common factor, highest common factor. If I want to do that, I can do that. I can factorize by 2. And if I don't want to factorize by 2, I can just leave my answer like this. 70